let's talk about the control scripting language. So here we are. Chapter 9, Control Programming, the control language. So we already talked about that a little bit. So to summarize, control scripting language is taken to process data points and also for animation of screen objects. So we are using this control scripting language in so-called Control Manager to realize the business logic of our project, and in user interfaces for the human-machine interface and the screen animation and all that stuff. We will always link data points to screen attributes with a so-called DP Connect, which is more or less a subscription from a graphical object to a data point element, and it acts on changes of the data point element. So then a callback function or a class object can be executed to act on data point element changes. We are taking the control for generating the user interface system and for to control all the states, right? So control is similar to C with some differences. For example, counting in table rows counting are starting, the first row has really count number 1 and not 0 like in C. Control is a case-sensitive language, so we distinguish between upper and lower case. So be carefully with to avoid typos, and also use the tab key on your keyboard to use autocompletion. Anyway, we are dealing here with an interpreter language, so no compiling, no linking. We can be time or event driven. Best practice will be event driven, and we have multi-threading capability inside the language. So then we have types of execution, for example, immediate, so changes on the data point attribute automatically trigger a control function. Here we are dealing with a so-called subscription, or the control function will be the name DP Connect. Or we are dealing here after user input. So the user gives some data in the input field, and then the data is processed, and the system reacts automatically on changes to the data point. Or it does not. It does not automatically react to changes to the data point. It's implemented that the user will do that. Or we can also implement cyclical things, right? So we have also the possibility to use the inbuilt scheduler, or the time functions, or we will write loops which do cyclical things, but only take it if there is no other solution. I would say most of the things can be done with some scriptions in here. So to the construction and the syntax, each script has a main function, and the main function normally doesn't have any parameter. The main function is always executed first and defined by opening and closing curly brackets for the statement block. Then we have also variables. More or less we have the same variables available as on the data model itself. So we have integers and floats and booleans and strings, so that are the simple ones. Recommendation from my side: if you take define a constant or define a value to a boolean, you will do it on scripting by the wording false or true, or uppercase false and true. In the para itself, if I simply have false and true, you can also take 0 and 1 to define the value. So that will be faster if you do it with the num block on your keyboard. Then some recommendations to variable names. So the first character must be a letter or an underscore. Again, program distinguish between upper and lowercase, and some naming convention, you can say all uppercase, that will be constant values. Leading uppercase character will be a global or public variable, or lowercase or mixed case, or best practice camel case for variables used inside a procedure. So I will use camel case, and I will also use spelling names on the coding, also with the information of type in the name. So I will do a little prefix if I'm dealing with a string a variable, then I will implement an S. If it's a float type, then I will do an F inside, but you will see later. We need to declare variables, so simply with variable type followed by variable name, and then we have a semicolon. For example, int x, so x will be a variable with the type integer, or here string s user, give an s inside the variable name to know exactly that it's a string type. And you can also do assignments here and define that the s color is red on the declaration of variables. That's also possible. And of course, more variables in one line separated by a simple comma. We have comments, so simply use // to comment a line, or /**/ for a block. Or I highly recommend the feature inside the script editor where you can go through the menu and you mark simply a statement block, and then you go to the menu and say please comment all, which is marked. So that's the most comfortable way to make comments. Or there's also a shortcut available to do that. Operators. So we have plus, minus, divided, multiplied, and modular. Greater else, less else, is or not is, logical operators like and or assignment operators. And of course you can also mix that completely up, as you noted from C, because I'm not the programmer, I'm the trainer. I've always troubles with this style of code. I like it to have it simpler, like that here or that here. So we have postfix and prefix available for our running variables with I++ or the ++I or I-, or minus I, and so on. Should be familiar for everybody in here, I would suggest. If and else is available, so if expression executes statement number 1, else if expression executes statement number 2, and everything else executes statement number 3. Syntax of a control function more in detail. So we have the return type, the function definition, and then the function parameters if needed. Opening curly bracket, variable declaration, statements, closing curly bracket. And now let's talk about the first 5 control functions which are available in WinCCA, and that are more or less the most important ones. So the first is the dpconnect, as mentioned before. So we can define with the dpconnect, we can establish a listener or a subscription to a data point element. In detail, it is a data point element attribute, like the original value. And related to that, we can, if there is a change on the data point element attribute, the system will execute a callback function. And this callback function has also defined with the dpconnect. So the dpconnect comes always with a callback function, or in detail also able with a class object. So for example, dpconnect, that's the definition of the callback function, which will be defined later. Then you have here the data point element address string. So in our case, it's not valve1, it will be d1.response.actValue. Then we have column and the online dot value. Later we will also talk about why there is a dot and why there is a column and so on. A dpconnect is a reading function, and automatically, if we're using a dpconnect, the system knows to look to the online value by default. So we can also skip that here if we using this default way. In other words, if we look here on the architecture, and I will take now here this view of the para, then I can go here and say I do a dpconnect and name the callback function workcb, and then I'm addressing here, let's say d1 dot response dot here we have another structure. Let's take for that example command dot setPoint. And I can skip here the column and the definition of the online value of the setPoint, because if I skip it, it's automatically pointing to the online value in here. So if the system is reading that line of code, at this stage, listener is established, and if there is a change on the data point element, the callback function is executed. And in the callback function, there will be, if I'm connecting to one data point element here, there will be two parameters. The first parameter will be the data point element name. So more or less I have to define a string variable where d1 command setPoint is stored, and then if I know d1 command setPoint is a floating type, we can see that here, then I can also do here float dpe value. Okay, so the value and the address of the calling data point element is available in the callback function and has to be defined if you use it or not. And here I need an opening and closing curly bracket. And let's say debug_tn. So debug_tn is posting as an output inside the log viewer. And let's say every time the callback function is executed in the log viewer, there's a posting done. So again, on executing dpconnect work callback d1 command setPoint, a listener is established, right? So there is a subscription to that data point element, and it will be linked to this callback function. If the value of the setPoint changes, then this callback function is executed. And this dpconnect, this listener, will live as long. So if I'm using that in a user interface panel, it will live as long the user interface panel is executed, so in the runtime. If I close the panel, automatically the system will send a DP disconnect and delete this this subscription or this listener. So I hope that's clear. Let's go ahead. So that is the DP connect. Good. To modify or to query data point elements attributes, we have a DP get or a DP set. So the DP get to query information from a data point element and store it in a variable, or a DP set to simply set a value to a data point element. So for example, let's do a DP get, then we define again the data point element address string. It's a string, so we are using quotes, and then we are storing the data or the value from the online value to the variable set point value. Or we do a DP set, which is then taking the address data point element address string valve1 command set point and pointing to the original value and storing 40.5 on this data point element. Here again, by default, the system will always try to read from the online value and always write to the original value. So you can skip this definition here because it's done by default. So I would suggest simply skip it if you use the default. And if you want to alter other data like other configs, you can also make a DP set to the PV range and change the behavior of it. Then write here PV range and the attribute of the PV range you want to alter and simply do it. So DP get and DP set. Let's also cover the last two functions. So if you are able to change data point element attributes, there should also be a way to change attributes of graphical objects, and that is done with a get value and a set value. So for example, I take a get value for rectangle 1, so that's the object name of my first rectangle, which was auto assigned because I did not do a naming. Change the foreground color, so the color of the border, and now read the foreground color and store the color inside the variable color1. Or set value, where we add this rectangle 1 and trigger the property visible on true, which indicates that this was before false, so invisible. To be honest, I do not do the coding with get value and set value because the alternative way to address graphical objects is much more easier. Because with auto-completion, I simply start to write the object's name, and then I do auto-completion, so it will auto-complete that. Then I do a dot, and then I get all options of properties in a box in the script editor, and then I simply choose visible by keyboard with the arrow keys, for example. You will also see, if we do the coding, how that works in detail. Okay, something to the script editor in WinCC COA. So we are using colors, and you can also change these colors. For example, strings will always be purple, and functions will be blue or becoming blue if they are written correctly. Before they will be black, and so on. So keep in mind, on this stage we can also change the settings and the coloring inside the script editor. We have tooltips and auto-completion, right? So if you write, I would highly recommend to simply write everything lowercase, then hit the tab key on the keyboard, and then you will get a box, and you can choose then whatever you want to take, right? So arrow keys, enter key, tab key on the keyboard is helpful. Or you simply write it and you will have a tooltip in here. Or you can also make a right click on the function and open the help as a split screen in the script editor, which is also a very good idea as a beginner to read the syntax and all that stuff during coding. And also, if you define a variable before, then the variable is also available in the auto-completion box. Okay, we already addressed data points, but let's also see the 6 parts behind the address. So what we have seen was the data point name, then the dot notations, and then the config and its attributes. What we not realized is that the first part of the address is the system name, which was simply not taken if you code on the host system, which I highly recommend. Do not do addressing of the system name if you deal with the host system, because if it's not declared, then it's automatically for the host system, and I don't take care about the specific unique name, right? If you deal with a distributed environment and you want to change data point elements from your system and you want to address the data points of another system, you will need the system name, which has to be unique to know where to go on which system, and then you need that. On the host system, we will always skip that. Be carefully, if we use the wizard, there will be always by default including system name checked. So if we're using the wizard, we should always decheck this option later on. Then we have the data point name. Here on the data point name, you can see the dot is not inside this hard bracket for further data point elements on deeper stages. So if you only want to address a data point name, it will always be the name and the dot if you are addressing, for example, only D1. If you go deeper, let's say D1 command set point, then it will be data point name dot data point element dot data point element. Coming to the column, it depends. By default, reading or writing, so writing original value is default, and on reading default online value is default. If you address these ones, you can completely skip that part here. If you address other configs or you want to read the original instead of the online, then you have really to define it in here. Before we have seen the 2 dots, because an original on an online does not have a detail, right? But we have to have the same way to address things. That's why we have then a dot. If you, for example, want to address an alert handler, there are details available. So there can be information in here. Let's go through this little game. So we want to address here the original value of the set point. So we start on the host system without a system name. That's why we have here this hard brackets. So we take D1, and D1 is here. Then we go take command, so dot command dot set point column underscore original, and the attribute in that case is value. Should be clear and very easy to code, because also auto completion is available here. Only needs a little bit of practicing.